Welcome to the Dassault Systems presentation. To get started with this session, we wanted to start with just 4 things to know about circularity. So 1, without it, there is no net zero. 2, it's a simple idea whose time has come. 3, progress is being made, but not at all fast enough. And 4, it's about changing materials, but mostly about changing mindsets. So without it, there's no net zero. Today's greenhouse gas emissions, if you look at the total output, 55% come from energy production and 45% from the production of things, materials and products. So even if we green our entire energy system, what this means is we still have 45% of the emissions to deal with. And that's where the circular economy comes into play and helps us. So the circular economy, many of you know this idea. It's very simple. The idea is that today we are working in a linear economy. We take resources from the natural world, we make things with them, we consume some of it, but mostly we throw most of it away. And the idea of the circular economy is to change that dynamic and turn that into a circle. So we are taking natural materials, but then we are doing 3 things. We are designing waste out of the system as much as possible. We are keeping those materials in the system, and we are trying to regenerate the natural systems that produce those materials for us. So from linear to circular. It's a very simple idea. And it's a simple idea whose time has really come. So if we look today at the way our economy works, in Europe today, 92% of cars are sitting unused, 35 to 50% of offices are unused. This is before the pandemic and during office hours. So what this means is we have a system we live in that is full of waste. And when we do try to deal with that, for example, in the area of plastic packaging, where we're trying to recycle that material, we are not very good at that. So only 15% of plastic worldwide was recycled in 2020. And all of that means that we're on track to consume every year about 2 times the natural resources the planet can regenerate. So this is not just a greenhouse gas crisis, this is a global resource crisis that we are in, and we need to deal with it very quickly. So what's good is that there is some progress being made. So what you see here is an example from Australia, where they are working progressively on waste export bans. So it's funny how when you say, okay, we can't send this waste and this trash off anymore somewhere else, suddenly people get very creative about how to deal with it. So how can you reduce the consumption of it? How can you recycle more of it? How can you build the infrastructure to deal with that waste differently? And so in this example, what Australia has done is they start with one material. So in January of 2021, glass scrap is being banned for export, and progressively different materials and different types of products will be banned. And this type of policy change is incredibly transformative, and we are seeing it happening more and more across the globe. The problem is it's not happening fast enough, and it's very heterogeneous. The policy frameworks around circularity are still very heterogeneous. And if you look at the share of municipal solid waste sent to landfill last year, for example, you see still massive amounts of waste just being thrown away, buried, burned, disposed of without sort of this mindset of circularity and reuse. And I've highlighted here 2 examples. You have 2 countries that are actually pretty advanced in their thinking, Canada and the UK, with vastly different outcomes. So 75% of waste goes to landfill in Canada, 14% in the UK. And what's funny is if you look at their policies, both Canada and the UK are doing a wonderful job on policies, not only about how to deal with waste, but also about the materials they're using. So recycling, compostable, reusable materials for packaging, for example, will be mandatory in these countries very, very soon. But if you remember the last slide today, that doesn't have a huge impact on the amount of waste sent to landfill. So what that tells us is that it is about changing materials, but there's something else more important going on here, that it's mostly about changing mindsets. I think we've all been told that essentially the way we get to better outcomes for human beings is we produce things, we sell them, that grows the economy, so more stuff equals more GDP equals better outcomes and more well-being for people. And what we've seen now is that is actually not the right equation to be thinking about. The way we are manufacturing and consuming goods is having a very detrimental impact on the planet, and we are now in a full-out ecological crisis. So what we need to do is completely change the mindset and switch to a mindset where we say, let's focus on increasing well-being, which has to do with switching to what we call also at Dassault Systems, the experience economy. So how can people have the same quality of well-being, health, happiness, etc., without sort of so much stuff, without buying and consuming and throwing away so much stuff? So how can we switch to experience-based economy because that's going to be the secret to future growth. So that's a pretty fundamental mindset shift, and that's why we call it a very simple idea when we talk about circularity, but one that is extremely hard to get to. So we're excited to be helping our customers with some of that transformation, and we will hear more about a very specific example in the next few minutes. So, Thomas, as a global expert on energy and materials, can you tell us how we can get towards more circularity and how we can move away from this linear carbon economy we have?
Right, that is the key question, Alice, because indeed the current economy mostly runs on carbon. So today, more than 80% of the energy we consume is from fossil fuels that we burn, and we've been burning for the past century and even more for the past few decades. And we have to transition away from that. The good news is that the share of electricity is increasing, and that represents a unique opportunity to transition away.
And tell us how or why electrification is such a big game changer for the energy sector.
So electrification is important because electricity can be produced with different kinds of primary energy sources like nuclear or renewables, which are low carbon. And as a matter of fact, for the past 2 decades, the global installed capacity of renewables has been surging, and this is just the beginning. So in short, this means that low carbon electricity will be able to provide low carbon energy to the industry and also to decarbonize special sectors such as transportation sector, which today mostly runs on fossil. So electrification is key.
And can you tell us now a little bit about how Dassault Systèmes helps shift towards this circular low carbon economy?
Right, so Dassault Systèmes is involved in the 2 approaches that are key to transitioning away from heavily carbon intensive energy. The first one is with nuclear. Dassault Systèmes is heavily involved in nuclear power generation and also nuclear research and development projects globally. Why is this important? Because nuclear, again, is one way to produce electricity that has a low carbon impact, and a lot of the nuclear waste can be reused again and again in nuclear reactors in what gets close to circularity. So this is very important. So we are active in traditional large-scale nuclear power generation projects, also in new kinds of nuclear projects with small modular reactors, as well as in nuclear research and development projects like the European Spallation Source in Sweden, where new breakthroughs are made on new materials and new ways to use energy. So nuclear, why is it so important? It's so important because the cost of nuclear electricity will very much depend on the cost of the nuclear project in the beginning. So you have to be efficient in the way you design and build nuclear power plants. This is why it's important. And this is extremely difficult because there's a lot of different disciplines that are active at the same time on those projects. So it's very important to create or recreate information traceability between the different specialists so that you're able to be efficient in your engineering. And once the engineering is efficient, you have to be efficient during the construction. And this is very important because construction involves thousands of people working at the same time, and this co-activity creates some risks to delay the project and also physical risks for the workers, and you have to de-risk all of that. This is why the 3D Experience Twin provides a way to harmonize all this information and the activity of all parties between the engineering disciplines and the field workers. This is very important because the price of the electricity that will be generated for the 60+ years of the power plant will very much depend on how efficiently it's been designed and built.
And how about the role of Dassault Systèmes in renewables, this other clean energy source?
Right, so renewables is the other low carbon option, and it's also circular because renewable energies and renewable devices can be recycled. So there is this learning curve principle by which each time we double the number of devices that we have produced, whether it's solar or wind, the price will reduce by something like 15%. So it's very important that we help optimize the design of those devices so that they are built efficiently and that also they can withstand the most extreme conditions. So we can see a number of examples of the areas where we have to optimize the way they operate, the way they are designed. This is sometimes very demanding, and this is a domain that is still relatively young. One of the objectives we have is to continue to reduce the cost of renewable energy to ensure that it is affordable to all and that it can truly replace fossil fuels. And for that, we have to continuously innovate in the design, and thanks to the 3D experience twin, we're able to iterate faster around different designs and to make sure that the first prototype will be running at full scale with no surprise. So a very good way to optimize the design itself. But going beyond that, we have to also understand how those designs will behave in their environment, how they will withstand the most demanding conditions. So also what is important is to understand how they will behave related to the local community. Will they generate too much noise, etc. So these kinds of simulations, we're able to perform them leveraging our expertise and know-how that we have built among many years, for example, in the aerospace industry. So designing the device is important, and also designing the way to produce it with people and with machines working collaboratively. Beyond that, once those devices are outside of the manufacturing plant, the 3D experience twin will be able to connect virtual and real and continue to be here to optimize the way the devices are operating on the field and allow to correct some of the operating parameters. And as we go further and as we install more and more renewable energy devices, we reach some areas where the conditions will be tougher and tougher. This is the example that we see now of offshore wind power, which is a very harsh and demanding environment. And in the end, we'll get closer and closer to local communities, and we have to make sure that we minimize disturbances to these communities.
So what is the key to enable a flexible low carbon power system, but at scale, beyond these individual examples?
That's an excellent question, Alice, because indeed, nuclear is not always the most flexible electricity system, and renewables are intermittent. So the grid, the power grid, the network will play a key role balancing all of that, and will be helped by millions of new devices that will come to the grid. And those new devices are the electric cars. So indeed, electric cars are a huge opportunity for the power system because they will represent like a virtual gigantic battery that will be deployed on the grid, and that will allow to compensate for the intermittency of renewables and to boost the flexibility of nuclear. So this is a very, very important enabler to these low carbon power generation options. And as you see, today already the standard internal combustion engine production has peaked, and all of the investment that has been committed by all the world's largest automakers is about electric vehicles.
So about electric vehicles, we know that the heart of that story is really the battery. So can you tell us more about that and how it's working?
Yes, indeed. So with the 3D experience twin, we dive deeper than the car and we look at the battery pack, which itself is a critical component of the car. First, it is a structural component. It plays an absolutely essential role in the structural integrity of the car, of the electric vehicle. So it has to be simulated against all conditions. And inside the battery pack, of course, are the individual battery cells, and we also have to model the way they will behave together, for example, how they will dissipate heat and how they will withstand some shocks. Now, zooming again with the 3D experience twin, we can go down to the level of the individual battery cell. This is an item that will be produced by billions very soon in the years to come. And because it will be produced by billions and because it will last for many years, if not decades, it has to be simulated in a very accurate way. And it has to be simulated for the most demanding conditions and also for some of the extreme behaviors that may happen. without the need of producing a lot of pre-series batches and without the need of harmful and damaging testing. And when calibrating very well simulations versus tests, we gain confidence, and here again we are able to innovate with new chemistries and with new designs that will allow to reduce the footprint of the battery and of the electric vehicle on the environment, while at the same time guaranteeing the safety of those vehicles and their passengers. So again, looking at the cell level, at a very low level, is absolutely essential to ensure safety and affordability. But we can go even below. The last level at which we will go with the 3D experience twin is the level of the materials inside the battery cell themselves, because it is optimizing these materials and understanding those behaviors that will be able to guarantee that the cell, the pack, the vehicle, and the overall energy system will work correctly. So in order to produce those billions of battery cells and electric cars, it's very important that the 3D experience twin is also able to model and simulate and optimize the behavior of the plant itself. So in a nutshell, we've gone to the lowest level, which is the level of materials, and there will be no circular energy without circular materials.
So what I hear you saying is that material circularity might be the key to a sustainable future. Is that what you would say?
Yeah, I would say that, Alice. In the end, it all boils down to materials circularity. Transitioning from a linear economy to a circular one means that the heavy industry of tomorrow will no longer be a linear heavy industry, but a circular one. And to do that, we'll need to be able to scale up recycling and to scale up multi-recycling. And to do so, we'll need to minimize energy consumption of recycling. And we do this by understanding the behavior of materials, which will also be used as catalysts to be able to separate valuable materials that are already out there to reuse them. The example we see here is the example of zeolites catalyst. Zeolites are microporous versions of the sand that can be used to separate and filter materials without using a lot of energy. And this is what we need if we want tomorrow to recycle at scale the content of these valuable batteries in electric cars and all of the performance specialty materials that we are using on a daily basis. So to do that, the 3D experience twin is able to help us understand around quantum mechanics the behavior of all of these materials that can help us recycle other materials. So these catalysts will be the key to help us become truly circular and scale up. Again, we will perform virtual experiments, look at different designs of those catalysts, and Dassault Systèmes is able to provide the 3D experience twin to do this, and is also able to perform this as a service contract, what we call outcome-based services, where Dassault Systèmes, we are using ourselves the 3D experience twin to decide the best design of some materials, either to produce high-performance batteries or equipment, or to produce catalysts that tomorrow will be used at scale in large factories to recycle close to where materials are used. So this is our objective. It's to get to a fully circular economy.
So we know when we talk about circularity, it's never a full circle. There's always some waste that's coming out. So how do we do to efficiently top up the materials we will need in the future?
You're right, Alice. We'll need to continue to extract somehow some of what we cannot grow. And that means that tomorrow we'll go towards precision extraction, whether it is precision mining or other techniques. And for that, we have to apply extremely sophisticated and science-based modeling techniques at a very large scale to the geological assets that we want to use, so as to pinpoint exactly what we want to use, where it is, and we can extract it without disturbing the environment. What is very important is that also we'll be able to design what we do around these geological assets in ways that they are reversible and that we can repurpose them to store. for example, to store industrial gases like hydrogen and even more green hydrogen that can help decarbonize some of the heavy industry processes like steel production or ammonia production. And to do that, we apply some of the parametric modeling techniques that we've been using for decades in the manufacturing industry to geological assets, so that we are extremely precise in the way we model, but also in the way we simulate. We're able to see how these geological assets will behave and how we will stress them so that we ensure that we minimize disturbances and risks to the surrounding communities, and so that we are confident that we can at the same time scale up and be precise in what we do with geological assets. So this is the end of our 3D experience twin journey from decarbonizing a large-scale energy system through nuclear, renewable energy devices, electric vehicles, batteries, circular recycling, and in the end, precision extraction.
So thank you so much, Thomas, for this amazing deep dive into how energy and materials can be both more sustainable and more circular. We're going to take everybody back up to conclude with a video about our vision about energy and materials and their sustainability right after this. Thank you all very much. Thank you, Thomas.
Thank you, Alice.
Every day, our lives are enriched by the energy and materials industry. From raw inputs for smartphones and infrastructure, to fertilizers for food, it drives prosperity across the world. Progress stems from the minds of visionaries who challenge the status quo. How will they shape tomorrow when technology is accelerating change, strengthening competition, and the push to a lower carbon economy? They will put experience to work, engineering, constructing, and operating for ultimate efficiency and safety across the value networks they unify. They will imagine the future to find the breakthrough, harnessing new sources of power, making novel formulations, and turning waste into new opportunities. With Dassault Systèmes' 3D experience platform, an inspired and connected workforce understands the past to navigate the future, modeling, simulating, and perfecting ideas to transform business and harmonize product, nature, and life. In a future made possible by virtual universes, experience it first.